All right. So write down this equation. We're just going to start solving right away. So before we solve, though, the first thing you're going to want to do is solving by substitution. I'm going to write some steps over here to the left. Is we want to solve one of our two equations for one of the variables. Solve one equation for one variable. So right now on the board we have 4 variables, correct? We've got the first x, the first y, the second x, the second y. Let's just put this to a class vote. How many of you guys want to solve? And we're thinking, make this as easy as possible. So let's write the word easy here. How many of you guys want to solve for the first x? We got 3, 4, 5, 6, 7 of you guys. 8. How many of you guys want to solve for the first y? Okay, 5. How many of you guys want to solve for the second x? This one right here. Nobody. Second y? Nobody. You do? You guys do? You just feel,
no, thank you.
Tyler, you just feel broke today? You just...
Yeah.
Alright. So, why would solving for that second y be a bad option? Just like, if you want to make this as easy as possible for yourself, right? Even if we don't know what's going on yet. Ethan?
Because 5 is wait, never mind, 16.
Okay. Well, think about it. So if we solve for the first x, we simply add y to both sides. So if we have x minus y is negative 3, you add y to both sides, we're done. Right? X equals y minus 3. What happens if we solve for this y, the second y?
Oh,
There's more steps, right? And you end up with fractions in the end. And so the next thing that we are going to do here, we solved one equation for one variable. Make it as easy as possible. Right? So whatever's going to lead to the least number of steps or the greatest or the best outcome, pick that one. And then we want to substitute what we just got. So substitute part 1 into the other equation. So what does that mean? We're going to take this, the y minus 3, because that's what x equals, right? X equals y minus 3. We are going to plug that in for x. Right? X is going to, we're going to substitute in y minus 3 for x. So the new equation will be negative 5, and then times y minus 3 plus 6y equals 16. So the only difference there is we just substituted in what x equals, right? X equals y minus 3. So we replaced the x there with y minus 3. It didn't replace the 5, right, or the negative 5. It just replaced only the x, because that's all that x equals. So we substitute that first part into the other equation. So then the next thing we need to do is simply solve the new equation. Yeah.
Would it be okay to plug in x equals y minus 3 in the first equation?
If you do that, so you can do that, the only issue is if you plug it back in, because that's where you got it from. So if you plug it back into here, you're going to end up with negative 3 equals negative 3, which is a true statement, which should make sense because that's where it came from. So it doesn't work.
Okay.
So the next thing you want to do is solve that new equation. So go ahead and do that, and let's solve it together as well. Felix, what would be the first thing you do when you're solving this equation? Just the first step.
Well, I would expand the brackets.
Okay. So what would that look like?
So that'd be negative 5y times plus 15 plus 6y. But yeah, equals 16.
There
So
we
then
go. Hold on. Lily, what would you do next?
You would add the 6y and the negative 5.
All right. So we get y plus 15 is 16.
Why is everyone laughing?
Just lock it up, Felix. Stuart, what would you do next? What's the last step to solve this?
Subtract 15.
There you go. So we should end up with a y equals 1 here. We solved that new equation. The last thing we are going to need to do is simply plug that into our first equation. Or substitute into that first step. So that's the x equals y minus 3. So we will plug that back in, so x now equals y, which is 1, so 1 minus 3, x equals a negative 2. Make sure to write your answer as an ordered pair. So to finish up, we're going to have negative 2 comma 1. We know that this comes from graphing, right? We know that the intersection of two lines is an ordered pair. That's what a solution is. So make sure you write your answer like that. And let's do a quick mental check. We're always going to do that. So negative 2, 1. Negative 2 minus 1 is negative 3. Yep, it works for the first one. Plug it into the second one. Negative 2 times negative 5 is positive 10. 10 plus 6 is 16. Yep, this works out. Always just do that quick mental check when you're solving these, so you know that you did it correctly. Alright, so this is all we're focusing on today, solving these equations. So I'm going to put some up here, and we're really going to go over them more or less one at a time, but let's just start with this first one. We want to talk about what variable to solve for. So what variable do you guys want to solve for in part A? Don't overthink the problem. What's the easiest variable to deal with?
X.
X.
Why?
Y.
Why?
Don't overthink the problem, right?
Why?
It's more or less a trick question. Just plug it in. It's already solved for, so I would not try to solve for x. Don't make your life harder. Nope. Y is already by itself, so just plug it in. This problem is almost done for free for you. X plus 10 is 2x plus 17. So solve that and plug it back in. And then I also want you guys to pick a variable to solve for in that second equation and go through that process. All right, let's get some work up here. So just given what's on the board, this blue equation. Alex, what would you do next to solve it?
I would subtract 2x from the side.
Sure. Minus 2x, negative x plus 10 is 17. Grace, what would you do next?
I'll subtract 10.
Okay, Grace, what's that final step then?
Divide by negative 1.
Alright, so we should end up with an x is a negative 7. Now, Sam, what equation do we want to plug that into?
I'm going to plug that into y equals x plus 10.
Yeah, that's going to be the easiest one to plug it into. So y equals negative 7 plus 10. So y equals 3. Our answer here, negative 7 comma 3. Do a quick check. Plug it in. Either do it in your head or on your paper. Pretty straightforward here though. 3 equals, so negative 7 would be 14 plus 17. Yep, that's true. 3 equals negative 7 plus 10. Yes, that's also true. So this one works. Right? Plug that in. Let's put this one up to a class vote. Which variable do you guys want to solve for? So who wants to solve for the first x? Nobody. First y. Alright, unanimous there. So let's do that. We will add the 3x to both sides. So negative 3x plus y is 5. Add 3x over. Y is 3x plus 5. Alright, so we are going to plug this into the other equation. Will someone read us that next line? What's that next line going to read once we plug that in, Austin?
3x plus 4 times 3x plus 5.
Alright, Riley, what would we do next in this equation? Just practicing our solving skills.
You distribute the 4 to the 3x and the 5.
20. Awesome. Denise, what would you do next? Awesome. Hannah, what are the last two steps?
You would subtract 20 and then divide by 15.
So 15x is negative 15. Divide by 15. Awesome. X is a negative 1. Oh, whoops. Oh, it's going to take everything. That's all right. So we then when we plug this in, I would just plug it right back in here. So when you do, you should get out of y equals negative 3 plus 5, which is better known as 2. So negative 1 comma 2 should be our answers. Right? Alright, so for our next one, for part C here, And I'll just rewrite D. What variable do you guys want to solve for?
Second, first one.
First one.
This one?
Yeah.
So that's a great one. 2 steps, right? Add the 2x over, divide by a -1. I would choose a different variable. Which one do you guys think I would choose?
Or
All the 4, that second x.
Okay, Johnny, why is that?
Because everything's a 4, and then you can just divide by 4.
Yeah, so I like that one because it's going to make everything smaller and easier to deal with. Now, all these numbers are pretty small, so it doesn't actually matter. So if you guys already started solving for the y, great, finish the problem, and I will go ahead and work through it by using that second x here. Add the 4y over, 4x is equal to -4 plus 4y, divide everything by 4, so x is going to be a y minus 1. I like that this is, it's not very complicated, right? It's very small numbers here, so plug that in to the top equation. So -2 times y minus 1 minus y is -10. Once again, you could have solved for that first y. You're going to end up with the same answer in the end. So I'll just keep going through this. -2y plus 2 minus y is -10. Combine like terms, -3y plus 2 is -10. So subtract that 2 over. -3y is -12. We can see that y is a 4. And then we can just plug it back into this equation. Right? Plug your y equals 4 back into here, so we should get out an x is 3. So x is 4 minus 1. X is 3. So 3 comma 4. If you do a quick mental check of that, plugging these numbers in, it does in fact work. All right, when we do this, what do you guys notice? So we already have y solved for. Plug that in here. Somebody read the next line to us. Once we plug in that y equals. Ethan, what's that next line?
8x plus -8x plus 4 equals 12.
Alright, so I was one ahead, so you plugged in -4x. So then you said 8x minus 8x plus 4 is 12. Alright, so everybody, what is 8x minus 8x?
0.
When does 4 equal 12?
Never.
Awesome. So we're going to write this as no solution because that's never true. Right? 4 never equals 12. That can never happen, so that's going to be no solution. If you were to have graphed this, these would be parallel lines. And the other option here would be infinitely many solutions, right? So the only way you'd get infinitely many solutions as an answer would be if you got 12 equals 12, right? Or just something, you got a true statement. So we got a false statement out, so no solution. A true statement would have told us it's infinitely many solutions.